In this example, we have figure 1 that shows a rectangle sheet of metal of negligible thickness, which measures 25 centimeter by 15 centimeter, and squares of side x centimeter are cut from each corner of the sheet, and the remainder is folded along the dotted line to make an open cubic box as shown in figure 2. So for part A, we need to show that the volume V centimeter cubed of the box is given by the function shown, which is V equal 4x squared minus 80x squared plus 4x cubed minus 80x squared plus 375x. So we start looking at part A. So if we are attempting to find the volume, so volume comes from length multiplied by width multiplied by height. So now for us to find the length, we can see we have 25 and we have x here, or actually we can write it here and x here taken away. So we can think of 25 and multiply by 2x taken away. So this is the length. Now we're looking at the width, so we can see 15 and we also have 2x's taken away. So we multiply by 15, take away 2x's. And for the height, we can see here that this will be also equivalent to x. So it will be multiplied by x. So now the next step will be here, multiplying these two, the brackets by each other, and then multiplying by x. So that will give us 375 take away 50x and take away 30x plus 4x squared multiplied by x. So the next step would be rearranging this, and also so we can see the minus 80 that we would have in the middle, and we can put the 4x squared at the beginning, and we'll multiply by x. That will give us the 4x cubed, and minus 50 and minus 30, that will give us minus 80x, and we would have the plus 375, which is 375x, which aligns with the answer we have for part A. Now for part B, we are asked to use a calculus to find the value of x to three significant figures for which the volume of the box is a maximum. So when we found the function for the volume, now we can for part B we need to find dv over dx to change. So for us to find, we can differentiate the expression that we have found from part A. So that will give us 12x squared minus 160x, and so this will be x squared here, and also we would have plus 375. So now at maximum value, we would have the dv over dx equated to 0. So now we can solve the expression by equating it to 0. So that means we would have 12x squared minus 160 x plus 375. So now for us to solve this equation, and of course equate it to 0. So for us to solve this equation, we can use a quadratic formula. So we can say use quadratic formula. So we have C, B, and A. So in this scenario, we would have, using the quadratic formula, we would have x being minus b plus minus square root of b squared minus 4ac over 2a. So that would give us x being, in this scenario, minus 160. So that's minus 160 plus minus root of b squared. So that would be minus 160 squared minus 4 multiplied by a, which is 12 multiplied by 365, all divided by 2 multiplied by a, which is 2 multiplied by 12. So now the next step would be simplifying this. So in terms of getting the values of x, we would have two values for x. So when simplifying this expression, we would have either x being equivalent to 0.03 or x being 10.3. So these are the values that we would have. So in terms of the potential, the 10.3, it doesn't look applicable because looking at the length, it doesn't align. So we say this is the correct answer, but x does not equal 10.3 since side length is 15, take away 2x, and if you multiply the 10.3 by the 2, that will be outside the range. So in this scenario, x will be 3.03, and this will be our answer for part B. Now for part C, we need to find to three significant figures the minimum volume of the box. So in this scenario for part C, we will need to differentiate again, find the second derivative. So that will be d squared v over dx squared. So that will give us in this scenario 24x minus 160. So now we plug the value, we say sub x equal 3.03 into d squared v over dx squared. So that will give us in this scenario 24 multiplied by 3.03, take away 160. So in this scenario, we will have the value being equivalent to approximately minus 87, which is smaller than 0. So hence, then the value is a maximum. Okay, so this will be our answer for part C, which is we needed to find that the value of x gives a maximum value of v, and this will be our answer for part C. Now we look at part D. In the previous part, we answered parts A, B, and C. Now we're looking at part D. We need to find to three significant figures the maximum volume of the box. So since we found the expression to be 4x cubed minus 80 x squared plus 375x. Now, and we found the value of x to be 3.03. We sub the value of x into the expression, so that will give us 4 multiplied by 3.03 cubed minus 80 multiplied by 3.03 squared plus 375 multiplied by 3.03, and this answer will be approximately 513, and the unit in this scenario, because it's volume, it will be centimeter cubed, and this will be our answer for part D of this question.